Okay, another type of factorising, guys, is difference of two squares. And with the difference of two squares, it's exercise 7.4 in your textbook, as well as exercise 7.6. So the first example I'd like to do is something like y squared minus 64. We need to ask ourselves, is there something common to both of these terms? And the answer is no. We may be able to factorise it by the method called difference of two squares. We need to ask ourselves, firstly, is this sign a difference? The answer being yes. Second question, does this have a square root? The answer yes, the square root of that is y. Third question, does this have a square root? The answer is yes, the square root of that is 8. So if the answer is yes to all three of those questions, then it's the method of factorising by the difference of two squares. With this, we end up with two brackets. The signs in the brackets are different. It does not matter which way around they are. The first term in the brackets is the square root of the first term. The second term in the brackets is the square root of the second term. So we have just factorised this using the method of difference of two squares. Factorising and expanding are the reverse. So you may remember from our expanding videos that if I had this, x plus 8, x minus 8, then what's in the brackets is exactly the same except for the sign. So if I was to expand this by the quick method, we would end up with two terms, always the different sign. The first term is this term here squared. The second term is this term here squared. Hopefully this shows you that when I factorise, that's what I get. And when I expand, expanding is the reverse of factorising. So if I'm asked to expand this, that's what I do, and that's what I get. If I'm asked to factorise it, then this is how I do it. I'll do another example for you. So the second example is something like m squared minus 100. There is nothing common to them both. That is a difference, and both of those have a square root. The square root of m squared is m, the square root of 100 is 10. So for this, I can factorise it using the difference of two squares methods. Sign is different. First term is the m, which is the square root mentioned here. Second term is 10, which is what's listed there. Okay, a third example for you. X squared minus 49i squared. There is nothing common to both of those two terms, but this is a difference. This has a square root, x, and this has a square root, 7i. So I can factorise using the difference of two squares. Two brackets, opposite signs in the brackets, order not important. First term is the square root of the first term here. Second term is this square root. So I've just factorised that using the difference of two squares. One last example, 5x squared minus 125. A lot of you will try and factorise using the difference of two squares straight away. But if you look, neither of those has a square root. 5x squared doesn't have a square root, and 125 doesn't have a square root. So that is not the right method initially. Remember, the very first thing we need to ask ourselves with factorising, is there a common factor? And the answer is yes. 5 is common to both of those. And if I take 5 out, I'm left with x squared minus 25. So I have factorised by taking out a common factor. Look what's in my brackets here. That's a difference. That has a square root, and that has a square root. So I can go further with this question. I leave my 5 out the front. I can factorise this here using the difference of two squares. So two brackets, signs opposite, order of signs not important. First term is the x, which is the square root there. Second term is the 5, which is the square root there. So that is some examples of factorising using the difference of two squares.